Hi, and welcome back to What Kind of Internet Do You Want? I'm Devon James, and today we're going to dive deeper into the Livepeer protocol. In our previous video, we discussed why video transcoding and format switching are essential and how they impact both creators and viewers. If you haven't seen that video, I recommend watching it first as it provides crucial context for this discussion. You can find the link to that video right here and in the description below. Now let's talk about how Livepeer works and how it can revolutionize the world of video streaming and distribution. Livepeer is built on top of Ethereum and has been running on ETH mainnet since 2018. It's been dubbed the world's first decentralized video streaming infrastructure. It has a native token, LPT, which is used for network orchestration and incentivizing the nodes involved to offer the best service possible. It's not an application or a single platform, it's a video transcoding and format switching protocol and network, and it's used by the developers of applications and websites behind the scenes. This is very much the right approach in my opinion, because in the world of online video, there really is just a single giant monopoly, and to some degree it's been maintained and reinforced by the centralization and cost of the limited options for transcoding as a service available to video startups. An enormous portion of the data transferred over the web is video. Currently, the combination of streaming and video on demand account for roughly 80% of all web data. And if a new video-based app or website isn't able to transcode and format switch its videos to best suit the needs of each of its users, their experience will be pretty awful. And before Livepeer, the only way a new video service could get transcoding and format switching for its content was through centralized solutions, often from the very same platforms they sought to disrupt. Back in 2015 and 2016, we had a web client and a fully decentralized client available for the Decentralized Library of Alexandria, which let anyone publish a variety of different kinds of media, including video. Most of the time, people would publish videos they had downloaded from YouTube, which meant they'd already been transcoded into formats that would play pretty smoothly over the web. But every once in a while, we got someone who wanted to publish a video straight out of their video editing software, and that always resulted in very unplayable results. If only we'd had Livepeer at the time. I say that because we did have the option to use centralized solutions, of course, but we were decentralization purists, and we didn't want to create a dependency on AWS, but also because those solutions were very expensive. Lots of startups have attempted to disrupt the big incumbents like YouTube and Twitch, but so far, only an app that's essentially been funded by a huge country's government, TikTok, has been able to make a dent. Why haven't bootstrapped approaches been able to do anything similar? Imagine a startup video platform that debuts with the promise not to spy on its users, and it has just the right combo of features, interface, stickiness, and community, and it takes off like wildfire, getting tens or hundreds of thousands of users really quickly. As a new service, it would want to avoid charging its users anything initially so as to kind of reduce the speed bumps to adoption as much as possible. But as soon as it starts to receive bills from the video transcoding service it depends on, it's forced to start selling its users' data, running ads, charging for subscriptions, or all of the above. This is exactly why Livepeer is so important. Livepeer is able to do the same thing that big centralized solutions do, but at a fraction of the cost. Like I mentioned in the last video, while Mux Video charges $2.40 per hour transcoded, and AWS charges $1.20 per hour transcoded, the Livepeer network costs only 30 cents per hour transcoded. So how does Livepeer achieve such a significant cost reduction? The answer lies in the decentralized network that Livepeer is built on, and the game theory behind how its service providers compete with each other. Unlike centralized solutions where a single company controls the entire infrastructure, Livepeer utilizes a decentralized network of nodes to perform the video transcoding and format switching tasks. This decentralized network offers several advantages. First, cost efficiency. By leveraging a decentralized network, Livepeer can tap into unused computational resources available on the network. This means that instead of relying on expensive, dedicated hardware, Livepeer can utilize the excess capacity of its nodes to transcode video at a lower cost. Second, scalability. The decentralized nature of Livepeer allows it to scale with the number of nodes on the network. As the network grows, so does its capacity to handle video transcoding tasks. This ensures that Livepeer can continue to provide low-cost transcoding services even as demand increases. And third, security and resilience. In a decentralized network, there is no single point of failure. This means that even if one or more nodes on the network are compromised or go offline, the remaining nodes can still continue to process video transcoding tasks. This makes the Livepeer network more secure and resilient than centralized solutions. So now that we understand the advantages of a decentralized network, let's take a closer look at the components of the Livepeer network and how they work together to provide low-cost video transcoding services. The Livepeer network consists of three main types of participants. The first is broadcasters. These are content creators like myself who want to have their videos transcoded and format switched for optimal online streaming. Broadcasters submit their videos to the Livepeer network for processing. Second, we have orchestrators. These users run software that lets them contribute their computer's resources like CPU, GPU, and bandwidth in service of transcoding and distributing video. Orchestrators can be anyone with spare computational resources who wants to earn rewards for contributing to the network. Third, delegators. These are individuals who hold Livepeer tokens and help secure the network by staking their tokens and delegating to orchestrators. In addition to a portion of newly minted tokens, delegators also receive a portion of the fees earned by orchestrators. So here's a high-level overview of how the Livepeer network operates. First, broadcasters submit their videos to the Livepeer network along with a fee, which is paid in ETH. Next, orchestrators on the network compete to process the video transcoding tasks by offering their computational resources at competitive prices. The Livepeer network then selects the best orchestrators for the job by considering which ones have the most support from delegators. Delegators choose who to delegate their stake toward based on orchestrators' price, performance, and reputation. This ensures that the most efficient and reliable transcoders are chosen to handle the video transcoding tasks, providing the best possible results for broadcasters. Once the orchestrators have been selected, they process the video transcoding tasks and return the optimized video files to the broadcasters. Orchestrators are then rewarded with fees paid by the broadcasters and a portion of newly minted LPT tokens. These rewards serve as an incentive for orchestrators to continue offering their computational resources to the network. Delegators who have staked their Livepeer tokens to delegate to transcoders also receive a portion of the newly minted tokens, as well as a portion of the fees paid to any orchestrators they delegated to. This incentivizes them to support the network and participate in its governance, and also to constantly aim to delegate to the most effective and productive orchestrators. I just mentioned that both orchestrators and delegators receive a portion of newly minted Livepeer tokens, but I wanted to explore a little deeper how the rate of newly issued LPT is controlled, because I think it's a really smart approach. With proof-of-stake networks, consensus and security are a byproduct of how many honest nodes are online and sharing network data. Since Livepeer uses a delegated proof-of-stake approach in which token holders delegate their staking to others as a way of voting on which orchestrators are the most effective and prolific, it means that there are multiple ways in which the network benefits from having a high proportion of its token holders actively staking their tokens, namely network security and transcoding efficiency. So, similar to Bitcoin and Ethereum, the network mints new tokens periodically. In Livepeer's case, rather than having a target block time, it uses rounds, which are based on Ethereum blocks. A round happens for every 5,760 Ethereum blocks. At the current average block time of just over 12 seconds, one Livepeer round is about every 69,638 seconds, or a little over 19 hours. So, to incentivize staking, the protocol mints new tokens in each of these rounds and awards them to stakers and the nodes they delegate toward. But the actual award amount varies up or down depending on whether the current portion of the network tokens being staked is above or below a protocol target of 50%. This is called the participation rate, since it's a measure of how much participation the network gets from its token holders. So if the participation rate is less than 50%, the quantity of new tokens minted will be a bit higher in order to financially incentivize more participation. But since if too much of the network's tokens were being actively staked, liquidity would become a problem. It also lowers the quantity of new tokens minted when the participation rate is above 50%. This approach dynamically encourages a high amount of security as well as liquidity. In addition to the core components of the Livepeer network, there is also a governance system in place that allows token holders to participate in decision-making processes. Token holders can vote on various proposals related to the network, such as adjusting the fee structure, upgrading protocol, or changing the inflation rate of LPT. This decentralized governance system ensures that the Livepeer network remains adaptable and responsive to the needs of its users while avoiding the potential pitfalls of centralized control. So to sum up, Livepeer is a groundbreaking video transcoding and format switching protocol that leverages the power of decentralization to offer cost-efficient, scalable, and secure video streaming service. By utilizing a network of transcoders and harnessing the support of token holders, Livepeer has the potential to revolutionize the way we process and consume video content online. And the numbers suggest it's on its way to doing exactly that. The network has nearly 6,000 delegators securing the network, more than 70,000 GPUs contributing to its operations. It averages 2 million minutes of video transcoded each week and has transcoded more than 215 million minutes to date. In our next videos, we're going to check out some of the apps and services built on top of the Livepeer network, learn about some of the interesting and unique features that can only be found on Web3 platforms like token gating, and we're going to dive a bit deeper into what it's like to be a service provider on the network. So thank you for tuning into this deep dive into the Livepeer protocol, and if you want to learn more about it, make sure you're subscribed so you get alerted when those videos come out. If you enjoyed this video, please give it a like and share it with your friends. You can find me on Twitter at Devon James and the Web3 Working Group on all socials at Web3WG. If you have any questions or comments about Livepeer, please feel free to leave them in the comments section below. Until next time, happy streaming.